Hey physical science students, this is Dr. B and we're going to talk about 9.1, Lab 9.1, Newton's Law of Motion. The first few questions on the lab are pretty straightforward. You can either go back to our text and look up Newton's first law, second law, and third law and fill in the blanks, or you can just look them up online. It's up to you. Make sure you fill in the blanks with something appropriate to that particular law. For the questions, I'll walk you through examples of how to do the questions and give you some hints on the ones that are more difficult. You should download this lab sheet from the Week 9 folder. And we will go through these questions one at a time. And I'll do some examples and I'll also provide some hints. So I have a Jamboard here, and this is question number 1, how much force is needed to accelerate a 66 kilogram skier at 2 meters per second squared? So I can grab a Jamboard pen here. And let's figure out what we have here. We have 66 kilograms, so that's a mass. And we have 2 meters per second squared, and we know that's an acceleration. What we're trying to find here, it says in the first part of this question, it says how much force. So I'm going to put a question mark under force, so we know that's what we're looking for. We know that Newton's second law, which is what we're going to use to solve these problems, is force equals mass times acceleration. Another way of thinking about that, if you've watched the video in the lesson, is you can draw a triangle like this, and you can put force on top, right here, and mass and acceleration. And then you can cover or cross out the thing that we're looking for. So we'll cross out force. And we know in order to calculate force, we need to multiply mass times acceleration. So let's set up our equation here. Our mass is 66 kilograms, and make sure you write your units. You need to show your work in order to get any credit. Times 2 meters per second squared. If I multiply 66 times 2, that's 132. I just did that in my head, but you can use a calculator. And that's kilograms. If I multiply the units across, it's kilograms meters per second squared. And that is the same as saying a Newton. So our result here is 132 newtons. Now, if you just write 132 newtons as your answer on the lab, you will not receive any credit. You need to show your work. So we'll move on to question 2, which is very similar to question 1. So I'm going to let you do this one. Notice we have a mass here, and we have an acceleration, and we're solving for force. So force is what we're solving for. You can set that up very similar to number 1. Number 3, we're asked to find the acceleration. So what is the acceleration? That's what we're looking for. We have 50 kilogram mass, and we have a force of 500 newtons. So this time they give us the force, but they want us to find acceleration. So we can set up our triangle here. We know that force equals mass times acceleration. So another way to write that is force at the top and mass and acceleration. So if we need to rearrange this equation to solve for acceleration, we can scribble out acceleration, and that helps us know that we need to divide the force by the mass in order to get acceleration. So our new equation here, when we rearrange it, is acceleration is equal to force over mass. So in this particular case, our mass is, our force is 500 newtons. And that's divided by our mass, which is 50 kilograms. They gave that to us in the problem. And remember, newtons is also another way to write newtons is kilograms meters seconds squared. So when we take newtons and we divide by 50 kilograms, the kilograms cancel, and we are left with meters per second squared as our resulting unit, which is good because that's what we want, because we want the answer we want is acceleration. So that's the unit for acceleration, so we know we've set up our problem correctly, and now you just need to do the math. 500 divided by 50, you can do that on your calculator. For 4 is pretty straightforward. You know that you need to solve, you have mass, you're solving for force, and you're given acceleration right here. So you have mass, you have acceleration, and you need to solve for force. This is pretty similar to number 1 and number 2. Number 5, again, we're looking for force. So it's a lot like 1 and 2. And we're given acceleration and we're given mass. So that one should be pretty straightforward. In number 6, we're looking, we are given the force. So we have a force of 250 newtons. We are given acceleration of 5 meters per second squared, and we want to know the mass of the object, so we're solving for mass. So we know our equation is F equals ma. Another way to write that is in a triangle here, with F at the top and ma at the bottom. So if we're solving for mass, we scribble out the m here, and we know our resulting equation is F divided by a, so force divided by acceleration equals mass. In this particular case, we know the force is 250 newtons. We know the acceleration is 5 meters per second squared. Let's see if we get the right units. Another way to write newtons here is kilograms times meters per second squared. And if that's divided by meters per second squared, the meters per second squared on the acceleration here cancels out the meters per second squared in the newtons, and what we're left with is kilograms. So kilograms is the unit we're looking for because we're solving for mass, and our unit is in kilograms, and now you just need to do the math. 250 divided by 5 equals the number of kilograms. Remember to show your work. Number 7 is also pretty straightforward. We have a force that we're given, and we're asked to find the mass. So it's similar to the last problem. So we have a mass, acceleration. We're solving for mass. We're actually solving for 2 masses. So we're going to have to do this equation, force divided by acceleration equals mass twice, because there are 2 bowling balls here. So each bowling ball has the same force, but there are 2 different accelerations. So we're doing 2 different problems here. So there's 15 newtons divided by 3 meters per second squared. And then the second bowling ball has a different acceleration. It's 15 newtons divided by 4 meters per second squared. So I'll let you figure out those two different masses. Remember your units. Number 8's a little confusing because they give you two masses. But if you think about it, if you've ever been sledding or you've ever had been on a bike, when they're moving, a bike and a rider, or a sled and the slider, act together. So you add these two masses together and use the sum of those two masses in the problem. You're given the force, you're given the mass, we're finding acceleration. So you cross out acceleration in our triangle here, and your formula is going to be force divided by mass is equal to acceleration. So combine those two masses in the problem and use that sum in your equation. Here's question 9. We know we have a force, we know we have a mass, we're looking for the acceleration. So if we're looking for acceleration, we know we come and cross this out, and hopefully you know what to do at this point with force and mass. Number 10 is another one that's pretty straightforward. We're calculating the force, that's what we don't know. We're given the mass, we're given the acceleration, so I'll let you draw the triangle and figure out how to calculate this one. So 11 is a little bit interesting here. We know the mass, we're given that. It's being pulled with a force of 40 newtons across a table. So we have a force of 40 newtons. I'll draw the vector. Remember, a vector has magnitude and direction. So this vector is 40 newtons. There's a force opposing the motion. So there's two forces here. We can draw a vector in the other direction that's 8 newtons. That's the frictional force. It's acting against you pulling the block. So you're pulling it this way and the block is resisting and wanting to go the other direction. So the force that we use for the problem is the resultant force. We have to add the force of you and the force of friction in opposite directions and see which one is bigger and how much bigger it is. And when we want to figure out how much bigger a number is, we subtract it. So 40 minus 8 equals 32. And that means there's a vector, the resultant vector, the result of subtracting 40 minus 8 is 32 newtons. So that's what we want to use for force in this problem. And how I found 32 is equal to 40 newtons in one direction minus 8 newtons in the other direction. So friction is subtracting. You're having to overcome friction with some of your pulling force. So your pulling force, even though you're pulling with 40 newtons, not all of that is acting on the block because some of it is used to overcome the 8 newtons of frictional force. So this question requires you to understand that all objects on planet Earth minus air resistance are accelerated at 9.8 meters per second squared. It doesn't matter if it's me or my coffee cup or a pencil or a feather. When we neglect air resistance, when we take air out of the equation, every single thing, despite the mass, is 9.8 meters per second squared. So it doesn't matter what the mass is, the acceleration of any object where there's no air resistance is 9.8 meters per second squared. That's just what gravity is on Earth. That's how we get accelerated by the Earth's gravity. And in some cases, air resistance is a big deal. Say you're a feather falling. But if I drop this coffee cup, air resistance would be pretty minimal. So number 13, we have a student pushing on a crate. We're going to assume the crate's on the floor with a force of 100 newtons directed to the right. So let's draw a vector to represent the force of the student pushing to the right. That's 100 newtons. Now it doesn't say anything about the block accelerating. So if the block is standing still, it's pushing back with an equal and opposite force of 100 newtons. And so if you have 100 newtons pushing this way and 100 newtons pushing this way, it doesn't move. And so the block, even though there's two different forces on it, it doesn't move because the forces cancel each other out. Okay, number 14, 200 newtons, we know that's our force, is exerted on a mass that's 40 kilograms, so we know what mass is, on a sheet of perfectly smooth ice, so we're going to assume friction is very minimal. We want to calculate acceleration. So we come down here, we scribble out acceleration, and we know we need to divide force by mass. So it's force divided by mass. And that makes it pretty easy to calculate A. B says if a second object identical to the first object is placed on top of the first object, what acceleration would a 200 Newton force produce? So we know force is the same, but mass, let's say we have a 40 kilogram mass skating along on our ice, and we put another 40 kilogram mass on top of that one. So what's the mass of 40 kilograms plus 40 kilograms? That's the mass you use for the second part of the problem. Those masses act together just like a bike and a rider or a sled and a slider. They're just, and you know instinctively if you've ever had someone jump on the back of your sled, that if you have an extra person in your sled, you act like one unit. You, the other person in the sled, act like one unit of mass when you accelerate. Same if you're giving a person a ride on your bike or you're pulling someone in a wagon. If someone else jumps in your wagon, it gets the wagon and the persons in the wagon act as a single mass system. So for B, you just add the two masses and keep going with the rest of the problem. Okay, for number 15, we have to know, living on Earth, that gravity here on Earth accelerates us at 9.8 meters per second squared. And if we're just standing around on a scale, air resistance is not a big deal. So if we have a person who has a mass of 60 kilograms, we want to know what their weight is if 1 pound equals 4.45 newtons. So what they're giving us here is a conversion from newtons to pounds. But first, we have to figure out what their newtons are, what the force is, how much Earth is pulling on them. And that's essentially their weight. So how much Earth is pulling on you, that force is your weight. So let's calculate it in newtons first. So here's our acceleration. Because we live on planet Earth, this person has a mass, and so we know the force in newtons is equal to the mass times the acceleration. So in this case, it's going to be the person's mass, which is 60 kilograms, which you measure on a balance. That's a relative amount. You're measuring the mass. When you measure someone's mass, you're measuring the amount of matter in them compared to a known. So if you think about a balance, it's got some known masses here, and you're kind of figuring out how much matter you have compared to a known amount of matter on the other side of the balance. So we know this person is 60 kilograms. We know they're being accelerated at 9.8 meters per second squared here on Earth. And so we can just multiply that through 60 times 9.8. We've got 588 newtons because that's kilograms times meters second squared. That gives us the unit newtons. Now we want to convert our newtons. We have 588 newtons, and we're given the conversion factor, 4.45 newtons equals 1 pound. And so we're going to multiply by this conversion factor. And a lot of students get confused about how to use the conversion factor. You want to use a conversion factor so that the unit that you want to cancel is on the bottom of the conversion factor when you multiply it. So we cancel out newtons here. And then we have 588 times 1, which is 588. Our unit's going to be pounds, because that's what's left when everything's canceled out. So our unit's going to be in pounds. And then it's 588 divided by 4.45, because those newtons canceled out. So you can end up doing the math here, and that will give you the answer in pounds. 588 divided by 4.45. Make sure you show your work. And the 2 extra credit questions you can tackle on your own. Thanks so much. This is Dr. B signing off on assignment 9.1 using Newton's laws.